Hello, good evening and welcome. So I need a tool, I'm making a tool, so I think I will enter this competition of competition-y thing, Emma's Spare Room. So here is my lathe and it has a collet chuck on here. I have the ER32 spanner, but the collet chuck comes with these pinholes. At present I use this bar. It's a little bit wobbly, but it does the job. Unfortunately it wears. Let's see if we can get a close-up of that for you. Can you see the line forming on it right at the end? And eventually it wears so much that I have to shorten the bar, because it will be too thin. It will just go pludge and come out. So that's the plan. Spanner for that. So let's measure it. Probably don't want to measure it with that, do I? No. That won't be very good. So let's go for a more precise measuring tool. And it looks like it's 99.98. There we go. So it's 100mm. I need a 100mm C-spanner with, wait for it, let's measure this as well. 7, who makes 7mm holes? I literally, good night. Who makes 7mm holes? Really? Right, so now I'm confused. I'm going to have to do all those measurements again because I'm getting stressed out at the 7mm holes. 7mm. Who makes 7mm holes? Anyway, right, so 100mm, sort of a half moony shapey 100mm. And then at the end of the 100mm it needs to have a little pin, 7mm, to hook into that. So it will sort of like, and then really I need to flip it round and then use it the opposite way. So yeah, use it both ways. And that'll be the spanner of choice for tightening the nuts at the back and tightening and loosening the collet at the front. I think the grass needs cutting. Quite a few clovers. Oh yeah, there's a moth. We got it. There's a moth. We're gonna bump. Oh, there's a bee. Let's get in on the bee. Look at that. Little bumblebee. We'll zoom in on him. Where is he? There he is. Look at that. Feeding on the clovers. This is why I let the grass grow a little bit. Give this guy a little bit of a chance of getting some stuff, and they love it. Look at him. He's loving it. Straight in there. So we're out at the grass that needs cutting, and here's the metal, and I've sort of made a rough graphite line with a pencil of the kind of shape. So first things first, angle grinder, clean all that mill scale off. Stage 1 complete. The removal of the ground in mill scale, pressed into the surface by the rollers, extremely difficult to remove, is complete. Next stage, marking out. Now obviously I could have used some kind of die to mark that out. A bit close enough you might see my markings. Yeah, I think you can see them just here, yeah. And then above it, there's one that goes round here. And then this one's a bit higher, it comes round and sweeps around here. So now I'm going to cut that out. And I haven't decided yet quite what I'm going to cut it out with. Either a manual hacksaw a powered jigsaw or the plasma cutter. It's going to be one of those. I am pretty sure I am scoring top prize for the most outrageous setup ever devised by man. So I've got a jacking piece here which was cut off from that piece, so it should be approximately the same height. Obviously that makes it safe. This edge hasn't been deburred, that's probably the dangerous part about it. As you can see, I have a reasonably big centre drill in there, and that's just letting me know where the centre hole is going to be drilled in that plate. Once that has happened, on that centre punch, which you may or may not be able to see there, I will drill a corresponding hole and hold that with a bolt. Yes, a bolt. And a toe clamp here, apart from when I'm milling this piece here, obviously. So I will take my time around this bit here, and when that's done, I will toe clamp it here, so it'll have one fix in there and one fix in there, which hopefully should stop it rotating. At that point I will cut the outer curve which dips. So the tool's going to be quite thick here, well, thicker here, and then it's going to tape off to a thinner bit at the end there. Okay, that's what we got after the melt. A bit of flashing in there, still some chips. So we have to attack that with a file now. So I'll tidy that up with a file, and we'll be on to the next operation, which is going to be welding a block of steel onto the end. A big jump there, so I can put the pin through it. So the outcome after a little bit of filing and sanding is quite pleasing. Around the business end, I can touch it everywhere without slicing myself. Now I haven't done the handley section yet, but that will be coming up shortly. It fits wonderfully. Bit of slack there, just as required. So if we bring a hole up, there we go, there's a hole here. The tool should sort of hook in and then come, well, put down there, should sort of hook in, and that little bit of clearance will allow it to go round and have a longer hook, which is desirable. I think usually these tools aren't quite round at the top here. By the by, mine is. Now I need to make a pin for the end, 7mm in diameter, to fit in that and attach it to the end of that. Anyway, that's going to be cylindrical, 7mm. This will be flat, and then it will go on there like that. So I might make it a bit thinner and slot it out, put it down, braze it, weld it, screw it on something to get that on there as a replaceable end. The diameter miraculously reduced from 1.5 inches down to 20mm, because I have some 20mm EN8 as well. So I'll quickly run you through this. Bit extra light on it. Turn on the lathe, put it into a low gear, bit more torque. Face is complete. Now I need to know how deep or how long the stub needs to be, and no longer than 8.57mm. So I think 8.5 will do it, or 8.3. Just gauge that by height. Ensure I don't go too far, and then I'll whittle that down. So do some OD now. Belt slipping. And I think really what I ought to do is tighten up the part, because it's not very tight. I'll just do that. So now you can see the main reason why I want this tool. I have to insert the pin here. Might give you a bit of a wider angle there, slightly wider, there we go. So I insert the pin in here, and then I'll put the tool on, and yeah, it wasn't very tight at all, was it really? Not at all. And I use that to tighten it up. Now it's putting a line around that, and as you can see I just bent it. Yeah, that was bent. So this will alleviate those problems. my little spigot sticking out. It is currently at 7.95 millimeters. So I am going to put a cut on of 1/4 mil. Right, 1/4 mil. We'll see if that takes off 1/4 mil. Or 1/2 mil. 1/2 mil. Right, 7.5 maybe. 7.48. So being predictable. So I will put on slightly less than 1/4 mil. That's 0.1 millimeter under. We'll put it 0.5 millimeter under, so that should be just slightly above 7 mil now, hopefully. Seven mil exactly. These were slightly above 7 mil, 7.05. So that should be a snug fit in there, but still give some clearance. Hopefully. Hopefully. Right, bing bang bosh, chamfer chamfer chamfer. Bing bang bosh, chamfer chamfer chamfer. Sweet as. Part done, I believe. Well, lathe work done on it anyway. I'm just going to flip it round and face it to length now. Time to see if the penny fits the slot. Yes, it does. Wonderful. 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 Okay, I've done some expert accurate measuring on this one and put a black Sharpie mark on it, approximately in the position. I mean, it's within a few microns obviously of where it needs to be. And the next order of operations, I believe, is I'm going to whack it in a Stephenson's collet block, and then I'm going to mill flats on the side of it to around about 2 millimeters either side, or 1.5 mil either side of that thickness there. Seeing as that is 6, I suspect I'm going to bring that down to 9 mil. Then I'm going to put a 6 mil slot through the centre of it and see how it goes from there. Okay, I need to do that slot, and I have an end mill. It's pretty butchered. For now, I'm going to sharpen it. Primary relief, or secondary. That last bit was just cutting the centre out so it doesn't rub in the centre. Let's go and see how she does. Next we need to hone the cutting edges. And I'm quite happy that they're good enough as they are, so I'm not going to take any material off. This is a coarser grit. And this is like a medium grit, and this is a fine grit. And as you can see, it's in very good condition because I've hardly ever used it. Just looking to polish the edge off. That fan you hear is the solar. There we go, got a lovely shine. I don't know if you can see that sparkling. I can certainly see it sparkling. Although that wasn't the one I was just doing. Or maybe it was. Now undoubtedly those flutes are not absolutely identical in height, so it might cut on 1, it might cut on 2, it might cut on 3 and it might cut on 4, but what I am sure of, it will definitely cut on one of those flutes, definitely. So it might be a single point cutter at the moment, it might be more than a single point cutter because I've just done that by hand. Let's see how she works. Now this is my mini mill arrangement, and I have the part in the collet block in there. A little 1/4 inch collet in there, hopefully it isn't too tight. And here's that end mill I've just sharpened. Obviously with you lot being in the way, it's not going to be easy. In fact, I'm going to reposition the camera so I can get to the handle on that side. Right, we'll go for the touch. That was the touch. And this being 20mm, I want it down to 9mm, so I need to take 11mm off of it. Half of 11mm is 5.5mm, so I need to set me bits and bobs up and I'll go in for the full depth of cut on the micro milling machine with the sharpened end mill. Okay, I've dialed in depth of cut 5.5mm, actually 5.4mm, because obviously I want to have a nice finish, so I've left a little bit for clean up. Maybe people can see why I have to sharpen cutters now. Anyway, we might try a bit of oil on it. So I've got my oil can at the ready. You can't really see it, it's so zoomed in. There we go, oil can at the ready, just in case it requires a little lubrication. I'm going to run this at 850 RPM and hand feed it. This is sadomasochistic engineering. See if she can do it. No, not going that fast. Put a bit more tension on the cross slide with the gib adjuster, just so we don't get too much chatter. There we go. And this is it, room to the kill. Right, let's take a look at the destruction. Well, I'm sure you can see that, it looks pretty spectacular. Let's get a bit of light on the subject. Too much glare. Look at that. I'm not even going to take a deeper cut than that. That is absolutely beautiful. Since accuracy is of the utmost with this, I've decided to crack out the indicators. So let's indicate it in. So I'll move the part towards me until we get a 0, and we will run across its surface. And it's a bit high on that side, so I shall adjust it. You see the spanner coming in? Yeah. Take half of that out. Go back to 0. Come back up till we get the 0. Too much. About there, it's 1 thou. Close enough. Now that's too high. Okie dokie. Just take that away. Oh, my arm's in the way again. So I've locked up the axis of the Y movement. And I'm just going to bring down the Z movement a little bit. About so much. I'll be a bit kind to it, I'll just lock it up. This is only 3:30 seconds, whatever it is, 5:30 seconds. No, oh yeah, look, 5:30 seconds, 3/16. Some weird fractional size. Alright, let's see what we've got out of that. A little brush. Well, there's a slot coming along there, isn't there? Okay, so now I need to know how much I need to take out the other side, so we'll try and get a measurement in there somehow. We might have to go a bit further out than that. So on that side, 1.65 on this side. Still not enough room. 2.86, I've got an extra millimetre on that side, and the hole is 4.72. 4.72, 4.73. So I need a millimetre to come out on it. So I need to push the table that way a millimetre, because this side's the thickest side, and take a millimetre out of that side. So the camera was on charge while I was drilling. It is drilled to 4mm. I'll just line it up by eye. There we go. She is completed. Apart from deburring and heat treating. That is the pin. Now, which way? Now, we have to get it on there, like that way. I can either put it straight on like that and just attach it, in which case I will have to take some material out, or I need to make it so it just rotates a little bit. Okay, I spent some quality time filing. I filed and I filed and I fitted and I filed. I used a bastard file and a mill smooth file mainly, and then for some of the curvature within here I used another bastard file. And then sanded it. I put a little notch in here, and I've rounded the outside a little bit as well. Inside I have taken out that bit that I said, so that's notched out there, and I've filed in an angle there. Okay, and then I've radiused the outsides sort of and put a little bit of an angle at the back there, and all that will make sense as soon as I fit it. So it goes in, there's a 4mm pin, just for demonstration purposes, and now when it's fully back it doesn't protrude, and when it's fully forwards it doesn't protrude. So it goes from one edge to the other and there's no protrusion at the top, at the front there. So now I need to make it hard so it will last some time at the end there. Okay, so that will be pretty hard now. It's gone back to being magnetic already. For a start, I'll grip it there, and obviously if it's soft the jaws will grab into it and mark it, and then we'll... That is hard. Just took the lime scale off. Lime scale. The jaws haven't marked it at all. If I try and squeeze it here it will fracture, so I've got to be careful here. Make sure it's So now I need to make sure that's soft, but not so soft that it gets damaged by little nicks and dinks and what have you, but soft enough that it doesn't fracture, because I can guarantee you if I put that in there now and try and use it, first thing it's going to do is fracture around the 4mm holes here. Right, what I was getting back to, I need to heat this up now, and there's two ways of doing it when you've only got a torch like this. One is to completely polish that back to being silver now, get all of that all that scale off of it, which is oil impregnated and a corrosion resistance now. Take all that off on the wire wheel and then heat it up until you get like a straw colour. The other way of doing it is put it in the oven at around about 250-300 degrees centigrade for around about half an hour. That'll take. So that's what I'm going to do. Okay, we've got the part on top of the oven here, and I've just turned the oven on. Its range goes up to 230, so I've got it just below that. We will open the oven. Is it getting warm in there? Yes it is. So let's put the bit inside. There we go. Let's see inside there, we go. And that's it, simple as. So I'll set that for an hour. And in around about 10 minutes time I'm going to just kick that back up to an hour and give it 10 minutes warm up time, and then an hour soaking at 200 degrees centigrade, and that will temper that to a very nice, very hard, very durable, non-crackable, tough steel. The oven has turned off. It is still hot in there, very hot. So I'll have that in there just to cool off. See if that's cool off the top now. Yes, it is. Okay, while the anvil pin thing has been cooking, I've just knocked up this. This is silver steel, 01 tool steel, and I've got a 4.1mm land here and a 2.6mm land here with 5BA threads on it. Need to make a nut, but this is going to be the pin. I'm going to harden and temper this. So, the front end of the, or the business end of the pin chuck is done. Got that much articulation. It's got a 3-point contact, 2 points here and 1 point at the front. It's a nice tight fit. It's not hard to put in. Just go straight in. Okay. So it's nice. I've used some silver steel for the pin. Just got to harden and temper that next. Okay, we have a new day, and on this precarious setup, getting a bit closer, there is some silver steel on the rusty piece of mild steel. They're the 2 bolts. Yeah, 2 bolts, no. That is the bolt and nut out of me new pin tool, and they are made of silver steel, so they are hardenable. Now usually you would quench these fast in a cold water or brine, or warm water they say, so like about 20 degrees. Now this oil is at 12 degrees centigrade. But oil, this is engine oil, does a slower quench, gives the part more toughness, more durability, less hardness. Hard to explain. So you're still going to have a hard, durable surface. And again, we're going to temper it. Tempering temperatures for silver steel are between 180 degrees centigrade to 350 degrees centigrade. So I'm going to do it at 220, 230 degrees, somewhere around about there, for an hour. Right, where's the bolt? Take the bolt out. The oven should be just about ready now. There's the nut. There's the nut. There you go. Now they're inside the oven. Zoom out of the oven a little bit so you can see them and stop shaking so much. Zoom out. They are just a little toaster oven. It does go up to 230 30 degrees centigrade. And I'm at full temperature. Yeah, full temperature. So we'll put that back up to an hour. So the timer's on an hour. I'll try and remember to come in and quench them again from 230 degrees centigrade. And they've got a lovely golden colour to them, so I will leave that oxidised, oil impregnated coating on them, and they should look pretty cool. Okay, so I used this piece of plastic at the end here and scribed around its radius to get that radius there at the end. Then I put a centre punch mark approximately in the centre, and I've used the dividers, which you can see there's a little radius marks. Can we get in closer? There you go, they're radiused, and the radius gets bigger and bigger and bigger. I would say good enough. That is good enough. Some sanding, and now I'm going to lob off that with a hacksaw, and file that to a round. Now I've got the shape more or less how I want it. It's gone a little bit skew with, but it's alright. I've got this. I don't know what the wood is, but the original garage, of which there's only a little bit left, which is that door frame down there, which will be coming out very shortly. That was the frame, so it was some hardwood from after the war, so I'm not sure if it's English hardwood, I don't know, but hardwood it is. And I want to use a handle, use it as the handle. Now this one here, it is split all the way down the centre, so I could put it into the table saw and split it in the centre and then thin it down, taking the split away from it. And this one similarly is split in the centre. Right, the fact that my workshop is not complete yet and digging stuff out inside there is nigh on impossible and takes ages, I'm slitting that by hand with the handsaw, like that. Then I'm using this extremely expensive block plane to smooth it up a little bit. Could do with them both the same thickness really, so there's going to be a lot of work going on in that too until I get them the same thickness with that little thing there. Right then, we are getting close. I have been whittling away at that with that, and they now are approximately, let's get the hand out of the way, the right size. A little bit of overhang on either side at the moment, so I'm ready to affix them and then do final shaping. Okay, so we have them drilled like this, and it's that good. There she be, she's all ready to go. So now I will commence to glue it. Righty-ho, the epoxy resin was getting quite hard, it's JB Weld, so I have trimmed the bottom. That will be sanded and hopefully there's no inclusions, but looks like I've got a couple, not to worry. So that's going to be like a black finish through the centre at the bottom here, and then it should taper out nicely at the bottom there. I've already curved the front of the handles round, so I've just got to put some shape onto them now because they're a bit square and a bit lopsided. The top will be polished steel protruding, all the way around the back will be polished steel protruding, and like I said, the bottom will be black. And she be done. Could do with oiling or varnishing the handle. There's got a bit of sanding left yet because the JB Weld is taking longer than 6 minutes to dry. That is 2 days now and it's still, wow, it's nearly there now, 2.5 days. So I need to sand this down so it's uniform colour, and then I'll put the surface finish on the wood. And I'm thinking either painting or maybe bluing the handle, although now the wood's on it I can't heat blow it, so I might have to chemically blow it. But there's the hardened and tempered bits all installed. I'll Loctite the nut on, and have a look in around here somewhere, around here. I will find out. I found it eventually. Are we in? No, there we go, now we're in. Now, it's even comfortable to hold now instead of a bit sharp because of the metal. So yeah, it's got a nice brushed finish, nearly finished that. Just, as I say, just some finishing little touches, but you get the general gist of it. I'm really happy with that. I didn't know how the wooden handle was going to turn out, but as normal, wood's very comfortable to hold in your hand, and yeah, it's pretty sweet. Where's that holder? We'll find it eventually. It's here somewhere. There we go. And with the flexible end, it's quite easy to find the holes. A couple of improvements I could make on it. I could make a brass buffer here, I don't know, a little brass buffer here, so when it comes down and touches the other side of the chuck, it ain't going to damage it. Of course I could have made the other, go on, get in, there we go. Could have made this end out of brass, but it wouldn't have lasted very long. So that was a rather pleasing project, to be fair. I mean, like everything, it could be better, could have been things I've done differently, but as it is great.